So in this question, we're told that a phone battery has a 20% chance of failing within a year, and if it fails, there's a 50% chance that the charging port will also fail. And if the battery doesn't fail, the charging port fails 5% of the time. So the first thing we're asked here, are these events independent? And then we're asked to find the overall chance of charging port failure within a year. So when we're thinking about independent events or dependent events, the thing we want to ask ourselves, does the outcome of one event directly affect the outcome of another event? And in this case, it clearly does, because if a battery fails, there's a half chance the charging port's also going to fail. Whereas if the battery doesn't fail, so if the battery is intact after a year, there's only a 5% chance the charging port fails at all. And so clearly the battery failing increases the chance of the charging port failing, and therefore these events are not independent. And so now we're going to move on and find the overall chance of charging port failure within a year. So in order to do this, I'm just going to draw a quick tree to basically illustrate the different chances involved here. So I'm just going to start off by putting battery here at the beginning. I'm going to put an F for fail here, and then DF for doesn't fail. And so if the battery fails, we have 0.5 here, because it happens 50% of the time. And then if it doesn't fail, we also have 0.5 down here. And now we're just going to do the same thing again, except for the charging port. So we're going to have F for fails, DF for doesn't fail. I'm going to do that for both cases. So in the case that the battery fails, the chance that the charging port fails is going to be 20%. The chance it doesn't fail is going to be 80%, which is just the 1 minus this 0.2 or 20%. And then down here, the chance that it fails if the battery doesn't fail is 0.05, which is the 5% from our question. And then the chance that it doesn't fail if the battery also doesn't fail is going to be 0.95. So that's going to be the chance that the battery doesn't fail if the charging port, the charging port doesn't fail if the battery also doesn't fail. So now we're just going to basically calculate the overall chance of the charging port failing. So to do that, I'm just going to switch color here. So we have 0.5 by 0.2, and we're just going to multiply these. So 0.5 by 0.2 is equal to 0.1. So that is our first multiplication done. And then we have down here 0.5 times 0.05. I'm just going to put an X here again for multiplication. And so we have, in this case, 0.025. So our overall chance is going to be 0.1, which is from the first case, and we're going to add to that 0.025, which is for the second case, and our overall chance is going to be 0.125, and that's also equal to an eighth, and that is our answer for this question.